We have part 2 test next time. So remember the format for part 2 was 2 FRQs. That's it. What should you be looking over? I would worry about just looking over the FRQs that I gave you. Yeah. Okay. So today I made a review for us. We'll just kind of work through some of this stuff. You should have pencil and or calculator out. I'll holler at you when it's a calculator thing you should be using. The questions that'll appear here will be similar to the questions I might ask you on the test or whatever, and it just kind of goes in a semi-random order as I just kind of did stuff.
Are we doing random groups like last time or not?
Oh, did we do that last time? I think we just.
Oh, I must be thinking of a different one.
Yeah, I think that was a different day. All right. So we'll start with a 7-1 question. This should be no calculator. So you have the integral of y e to the 0.2y dy.
This is no calculator, you said? Mm-hmm. Okay.
I don't think it would help you anyways, but.
Right.
Take a few minutes and we'll kind of run through what to do here. Sometime around the end of the day, I will post this PDF to OneNote also for you guys. So. Well, I'm thinking about it. Bet caught an error on one of the answers for the the FRQ things. So I updated that yesterday. So if if you printed off your FRQ answers or whatever, you may want to go back. It was just like one question or whatever I made a goofer on where I think I'd done part of it and then had to step away and came back and forgot that I had done some other part before it. But I fixed it. Hopefully you decided integration by parts would be the way to go on this. So your u should have been y and your dv should be e to the 0.2y. What's the complication with finding v? You have to do a u sub. So you have to do a u sub inside of your integration by parts. That's from the u sub. If you divide both sides by the 0.02, that's 5. 1 over 0.2 is 5. So the nice part is when you do after you plug in UV minus VDU, if you pull that 5 out front, it's really the same thing as dV was, so you can use that work again. And there's your final. Oh, yeah, thank you. Yep, I should have guessed I got to open up my editor here and put that in, so when I publish again, I have it. Yeah.
I'll try.
And that's dividing by 0.02 is the same thing as 5. So this is just right. Is that cool? So it's like easy U sub, but
Wait, U is 6. Or W.
it's a U.
Okay.
It's just a messy U. All right. You guys ready for the next one? Okay. Notice the label here. This is a 65N71 question. Again, there should be no calculator. It gets a little yucky at the end, but remember the average value formula? 1 over b minus a times the integral from a to b of f of x dx. So you're set up. Now we have to do a U sub, or I'm sorry, integration by parts. Because you don't know, we don't have an antiderivative for tan inverse, right? So U should just be tan inverse 1 over x. dv is going to be dx. So du is 1 over 1 plus 1 over x squared times negative 1 over x squared. You had to do a chain rule on that piece. But that simplifies nicely to just negative 1 over x squared plus 1 dx. And the integral of v is just x, so that's nice.
There's no other part.
Right, there's not a product there.
Yeah.
So your dx has to be your dv. That's the only thing you can integrate. So I plug the integration by parts formula in. Remembering, because it's a definite integral, I'm going to have to sub in 1 and root 3 for the uv part. And it gives me this second integral. So to integrate, really that's x over x squared, or negative x over x squared plus 1 dx. To integrate that, I have to use u sub. So the u should be x squared plus 1, the denominator. And the derivative of that, when I simplify stuff around, I get du over 2 equals x dx. Which makes this just plus the integral from 1 to root 3 of 1 over u.
The u sub times the derivative of the inside become negative.
This, because it was a negative x to negative 1.
And then move it to the front. Okay,
Yep.
gotcha.
What's up, Zoe?
What's up, brother? I had the right idea. I just
Yep.
Back a little bit to the channel. Wait, how do you do like the 1 over x?
X to negative 1.
Oh, and then.
So just negative 1 to the front, subtract 1 from the exponent. That's the negative 1 over x squared. I chose to write it that way because it was going to clear the fraction, the denominator, and makes everything look a whole lot neater. So anyways, after the u sub, this piece is the integral of 1 over u. So that's going to be the natural log. The 1/2 from the x dx came to the front. And I plugged the u back in and have those original bounds. Notice over here I went ahead and did the plugging the root 3's in and then subtracted plugging the minus or the 1's in. You can see why I said this is going to get a little yucky at the end. Not that it's hard yucky, it's just like, it's a lot to write. And the tan inverse of root 3 is pi over 6. Tan inverse of 1 is pi over 4. I went ahead and plugged the stuff in. So when I plug in root 3, that's going to be 4, root 3 squared plus 1 is 4. 1 squared plus 1 is 2. And then I just kind of clean stuff up over here. And then this is using the quotient rule for logarithms. That's natural log of 4 over 2, which is just 2. And then the coefficient of 1/2 can become an exponent inside the logarithm. Exponent of 1/2 is the same as a square root. And that's as good as I was gonna felt like doing. I guess I could have made some common denominators and stuff, but like, I'm good.
Where did the use of come from?
To do this integral.
Okay. Gotcha.
Again, because that's not one of our antiderivative formulas.
Right.
So, got to do something with it. We'd always prefer to do u sub over parts. So always look to see if it's a u sub problem before you decide it's got to be a parts problem. Because u sub is just the integral and you're done. Parts, you have to do another integral after you do the parts. You know, prefer not to have to do that extra step. That one, the symbol pushing got complicated on you there. But, and again, I'm just trying to get through a chance to look at all the questions. So I'm not giving you that much time to kind of look at these things. So like, don't feel like Mr. Kulik thinks I should do this in 3 minutes. You shouldn't do this in 3 minutes. It's not a 3-minute problem. Rita.
What were you talking about, like the quotient rule or like that?
So all I'm talking about is how I simplified this to here. So natural log 4 minus natural log 2 is the natural log of 4 over 2. And then 1/2 natural log 2 is the same as natural log of 2 to the 1/2 power. And that's that. So I just did some condensing there. Yep. All right, you guys ready for the next one? I know you're not, but okay. This one should not be nearly as messy. Again, you don't need a calculator to do this. This one says show that y equals negative 1/2 x times cosine x is a solution to the differential equation y double prime plus y equals sine x. How do we need to start this one? Got to find that second derivative, right? So that entails a product rule, correct?
You should take the 1/2 out, right?
You can ignore the negative 1/2
Until after.
and then just tack them back on whatever you get from your product rule. Yep. What's up?
Everything just connects.
Yeah. I mean, we've got to the point where like we're using everything we
Yeah.
have learned.
Everything's my toolbox.
And that makes it hard
Yeah.
because it's not really siloed anymore. It's just like,
Everything.
it's just all there, like a calc problem is just all of calculus.
Yeah, literally.
I'm also picking things that are a little bit more comprehensive to kind of get us, you know, preparing. Because it certainly seems like the AP likes to do stuff like that. Particularly on the free response questions. where you see like lots of different topics I kind of all pooled together into one question. So here's my first and second derivatives. That was the hardest part, because when you just plug everything back in, one half sine plus one half sine is sine. And you have a positive 1/2 x cosine x and a negative 1/2 x cosine x. They just cancel each other out. So we just have that y double prime plus y is sine. We did it. The hardest part was getting that second derivative correct.
So the 1/2 does distribute.
Yes.
Okay.
Mm-hmm.
Wait, so is the derivative of cosine is negative sine, right?
Correct.
Okay. That's why it's 6 plus.
That's why it became positive on the first derivative. Correct. Yep. Cool so far? So I did a product rule again here. So the derivative of sine is cosine. The derivative of x is just 1. And then I did the derivative of this. The derivative of cosine is negative sine. So the negatives canceled and turned into a plus. That's what you needed? Okay. This is messed up here, huh? I guess I must not have published it after I fixed that. Oh well. Try this one. It's a 9-2 question. Stop. I miscopied stuff. There's not an answer here.
This is that type of problem where you don't really have to write anything down, right? So
Correct.
do it in your mind.
Yes.
Oh yeah, wherever there's not a slope, that just means that the function is undefined. So it's either something over 0 or 0 over.
Oh, so we
Well,
can't.
actually, no, 0 over 4 would just be 0, right?
Yeah, so it has to be something over 0.
So these y should be squared. All the y's in the numerator should be 4 minus y squareds.
So a vertical slope is like undefined, and then like a straight horizontal slope is when it's equal to 0, right?
Oh, yeah.
Or are they both undefined?
So
No, you're right.
So a horizontal slope is when the derivative is 0. So you should see zeros at y equals 2 and y equals negative 2. And that's it. And none of these answers are right because of that.
Even when it's like squared?
even when it's squared. I think I just got looking between two different questions and copied the wrong stuff in. So just ignore this. I'll fix it.
Okay, so like the way you approach is you look at where like there's like a
I'm looking at the zeros first.
right.
Yep. So I look for things where I had that when I plug 2 and -2 in for y, I get a 0. And then if I had multiple of the same, I'd say, okay, well, what if I put in like, the point, 2, 1. I should be getting a negative slope out of that. And maybe that would allow me to differentiate between my two answers. Or if I plugged in the point like 1, -3, I should be getting a positive slope out of that. So I would do stuff like that to try to differentiate between once I got to 2 or 3, that it's like, okay, those all have the same point, like equilibrium values.
And if there's like a vertical.
That's a denominator equal to 0. Mm-hmm.
Thanks.
Yep. So I'll fix that for you guys. My apologies. This is an actual 9-3 question. Oh, yeah. Sorry, I'm just going to look at this and trying to figure out what in the great googly moogly did I do to that previous question that I just butchered the heck out of. That's the one that I copied the answers from, which is not at all the image that I picked. Good job, Kulik. Rita, anything you can do with numbers, you can do with variables.
Wait, it's like I just took like the p for the square root times.
So if you had square root 8 and you wanted to simplify that, how do you do that?
Like square root 2. Wait, I don't know what I'm saying.
Like square root 2 times square root 4,
Oh
right?
yeah, sorry. Okay, so I can do this.
So you can do the same thing with variables. So you can,
Very good.
right? Again, I'm just trying to like
Okay, that's what I was doing.
remind you that like, that's the set of answers I should have written there.
Right. So, and then yeah, once you like get the variables, I don't know. Yeah, go ahead. Right. I think it matters.
What's up?
Like, how do you determine what side you add, like, plus C?
No, eventually you want the p by itself.
Oh. Okay.
You want to get a p by itself eventually, so put the c on the side where it's, you don't have to like move it again.
But the P can be like P to the 1/2 or something.
Well, it should just be just a straight p when you're done. So at one point you should have a p to a power. So first step is I wrote that as root p, root t. So then I divided both sides by root p and multiplied both sides by dt. So that's p to the negative 1/2. So I did the antiderivative there. And this is t to the positive 1/2, so I did the antiderivative there. And I put the plus c on the side without the p. At this step, I went ahead and solved for the c by using the initial values of p, or t is 1 and p is 2. And that allowed me to get that c is 2 root 2 minus 2/3. So then I went back to here and I divided everything by 2 and then squared both sides to get to that. Yeah, Kate. So this is p to the negative 1/2 dp. So when I do the antiderivative, I add 1 to the exponent, making it p to 1/2 divided by 1/2. And that simplifies to 2 root p. Is that? Okay. And I have a 6-4 question. This guy's a multi-parter, so yep. Oh,
So that was
nope,
in
this is my
section
9.5
but
question.
it said 9.3.
Yeah, I don't. This is all. I don't know what's going on up here. I think
So
I
it-
just need to recompile the whole thing because
It is 9.3 though.
yeah, that's a 9.3. Yeah, this is a 9.5. Problem. Then now says it's doing a 6.4. I don't know. I have to go look at this. I did it quickly yesterday, and I guess I, when I got it to work and compiled it, I guess I didn't. Something didn't work. I don't know. Maybe I didn't compile it after my last update. Because everything, when I'm looking at the source code, it looks all fine, but
Wait, so this is 9.5?
this is 9.5.
Okay.
Definitely not solving differential equations in 6.4.
Yeah, it sounds like.
What?
Could you go back to the last slide? I don't know if I copied the answer that.
I'm gonna publish the whole thing to the OneNote. It should be P equals parenthesis 1/3 t to the 3 over 2 plus root 2 minus 1/3 close parentheses squared.
I don't understand why it's 1/3 and not 2/3.
Because you had 2 root p, so you had to divide both sides by 2. When you did the antiderivative of 1 over root p, you should get 2 root p.
Yeah. I just think.
So getting the p by itself, you divide by 2. That knocked all the coefficients down by a half. Isabel, you good?
Yeah.
No problem. Hopefully you all recognize that this was a linear differential equation, right? Now you had to do a little bit of rearranging. So I started by putting it in that linear differential form. So I have y prime plus p of xy equals q of x. So the p of x is just x. So my integrating factor is just e to the integral of x dx, or e to the x squared over 2. So I multiply that to both sides and then condense the left-hand side to just be I of x times y, the derivative of. And then the right-hand side is just x times that I of x. So the left-hand side, it's easy because the derivative just cancels out the integral. But to integrate the right-hand side, I needed to use a u sub. What happened to what? I just rearranged it so it's in that linear differential equation form of dy dx plus p of x y times q of x. So I just did a rearranging before I dove in, so everything was like where I expected it to be. So here, the derivative cancels the integral. This is just, when I do the u sub and integrate, it's just e to the u. And the integral of e to the u is just e to the u. So there's that. And then I have my plus c at the end. To get the y by itself, then I just divide by e to the x squared over 2. That cancels there. And then I have plus c. And then I wrote that with a negative exponent rather than writing a fraction because it's much easier to typeset with a negative exponent than it was a fraction, but the fraction would have been fine. Again, if you remembered how to do that, not bad. Jacob?
Why isn't it c over x squared?
Because I wrote it with a negative exponent.
Oh, I didn't see that.
Yeah, my cursor is probably in your way. So yeah, you could write it, you could leave it as c over e to the x squared over 2. That's fine. Means the same thing. It's just easier to typeset the negative exponent than it is just a fraction. So that's what I went with. All right. Here's my last block of questions.
6.5.
So the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine t squared over 35 cubic feet per hour, where t is measured in hours from 0 to 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by d of t equals negative 0.04 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour for t 0 to 8. There are 30 cubic feet of water in the pipe at time t equals 0. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval? 0 to 8. Which function is describing the water coming in? R of t. R of t is a rate, right? The answer we're looking for is just the volume. So how do I find? I use an integral to calculate the accumulation of that rate into a single quantity. So you're just integrating R of t from 0 to 8. This should be calculator, yes. You have no business trying to do this by hand. Absolutely use that calculator and use the heck out of it. Okay. So that's it. The water in is just the integral from 0 to 8 of R of t dt. Type in my calculator, press enter. Helpful hint, I would type R of t and D of t into the y1 and y2s. Because we'll use those, I think, several times. And then you don't have to retype it every time you want to use it. You know what I mean?
Yeah.
Helpful hint. Now, the downside of doing this is if you make a typo, it screws up all the problems. But on the AP, if you wrote like the integral 0 to 8 R of t dt equals, and you wrote the wrong answer, you'd at least get the point for the setup, I think. You know what I mean? Which is not the end of the world. It's not like you're zeroing out if you do something silly and like, type 2 sine of t squared over 35 or something. But as a word of warning, why don't you take a second and type in both R of t and D of t? So you don't have to come back and get them again. But those are the biggies that we need right away. All right. Is the amount of water in the pipe increasing or decreasing at time t equals 3?
Wait, what was the answer?
76 something or another.
6?
Is your calculator in degree mode or radian mode?
Oh, it's in degrees.
Yeah, that'll do it.
There you go.
Okay.
For real.
All right. Amount of water in the pipe increasing or decreasing at time t equals 3. Well, the rate of change for the water at time 3 is just the difference in R and D, right? Because R is the water coming in, D is the water going out. So I'm just going to calculate R of 3 minus D of 3. And since that's a negative rate of change in our water, is just means that the volume should be decreasing. We're losing water faster than we're gaining it at time t equals 3. Again, pretty easy to do, but you have to think about what's going on, right? But the way I read this is it's just I'm not worried about what the stuff is. It's like I have rate coming in, rate going out. So what's the rate of change at time 3? Well, just the net change at 3. So it's, in minus out. That ought to do it. Everybody cool? Again, not so hard, but like you do enough of these and it's easy to see what they're driving at. All right, here's probably the most difficult question in the set. It says, at what time t is the amount of water in the pipe at a minimum? Justify your answer. Well, I'm going to start by writing the equation for water in the pipe. So it started with 30, and then it's plus the integral from 0 to t of r of t minus d of t dt. So for the minimum, I want the derivative to be 0. So I take the derivative of both sides, 30 cancels out, and the integral cancels. Those should probably have been x's instead of t's. That's my mistake. I get this. I set that equal to 0. How did I solve this and get the t there of 3.27? How do you think I did that? Yeah, how did I do it in my calculator, though? y2 minus y1. I graphed it and looked for the intersection. Right? I just set my window from 0 to 8 and looked for the intersection of r of t and d of t. And then did like second trace and intersect. Is that okay? Never try to solve, if you have a calculator problem, don't solve anything by hand. Always just use your graphing calculator, like find the intersection or whatever. So I got that as one answer. Now it asks for a minimum over a closed interval, so I have to do the closed interval test here. So in addition to checking any of these critical values, I also need to check the start and end of my interval. So that's what I did here. I did W of 0, W of 3.27, and then W of 8, where this is what I'm plugging into. And again, I use my calculator to do that. I'm not plugging.
Like what we'll have on the test.
What's up?
Something like we'll have on the test.
For sure. Yeah, this is perfectly reasonable. In fact, it's very similar to one of the problems you saw on your on that practice AP stuff that I gave you to do on the synchronous day. Yeah, you should be able to do a problem like this for sure. So of those three values, which one is the smallest? That, yeah, 2796. So the absolute minimum occurs at time 3.27 hours. Again, remember it asks for what time, not the minimum amount of water in there. I wanted the time. Isabel?
I just don't understand like why you need to find the intersections here or to read up the radius.
Because it's equal to 0. R of t minus d of t has to equal 0. So I added them to both sides. I add dt to both sides, and I just need to find where r of t is equal to d of t. That's the intersection, right? I mean, you could type in r of t minus d of t into y3 and look for the zeros. You could do it that way also. That's fine. But that requires you now have to type those things in again. I pass, you know. I just graph it from 0 to 8 and look for the intersections.
And you said equal to 0 is actually the rate value.
Because I'm looking for a minimum or a maximum, right? I'm always looking for a critical value there when the derivative is 0.
Okay.
Is that,
Yeah.
Jacob?
I forget. It's been a while. What's the reason for using like the two endpoints?
Because it's a closed interval.
Okay.
So like it could be that we started really low, Like
Mhm.
we do something and we find like a minimum in there, but it's not actually the minimum value because it could be we started at, like you have to check the endpoints also. If this was an open interval from 0 to 8, then we could do like the first derivative test or second derivative test to determine if it's a minimum or not. Because it's a closed interval, we have to be more careful.
Okay. Couldn't you also solve or like find an intersection at an endpoint if it had like that 0? Or no?
You can't do
right?
the derivative at an endpoint.
Right. Okay.
That's the issue.
Okay.
Okay. Last part. It says the pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Right, but do not solve an equation involving one or more integrals that gives the time w when the pipe begins to overflow. So I said, okay, well, there's my water equation that I did before. So we're just T is W, looking to get that to 50. And I think from the previous one, I don't think I'm going to get over 50 before 8. So I think I'm in the clear there. But you could have also done this 50 here. And instead of 30, you could have done 48.54 plus 8 to W R of t minus d of t dt. Like that would be acceptable also, I'm sure. So if this was the 48 point whatever, 8 to W R of t dt, still equaling to 50. That I think would have been okay. Or if you had subtracted that over and found the difference, but like you could do this in a lot of different forms that are all equivalent. And I think that was my last one, guys. Yeah, that's the end. What do you guys think?
It's not bad, but
There's some stuff to brush up on, for sure.
it's like this stuff.
Yeah, this is what we're doing on Thursday. You get 2 questions. One will be an accumulation question, very similar to this. The other will be a differential equations question. Again, look at the stuff in the FRQs that I left you.
Sounds good.
You should be, if you look those over and you feel good on those, you should be fine. Yeah. I call this kind of question accumulation because you have 2 rates.
Yeah, I don't like accumulations.
Very classical free response question. AP likes these.
Is a differential equation like adding 5?
No. So like if you looked at the FRQs that I left you, none of the differential equations in those FRQs were linear. Like that's a separable differential equation. That's an accumulation question. This is an accumulation question. So is that one. This is separable. That's a separable differential equation. So is that one. None of these are linear differential equations, so they'll be like 9.3 questions, not 9.5. Katie, is that's what you needed?
Are we done with the review?
I think so.
Okay. Can I come up and ask you?
Sure. Are you guys happy enough?
Yeah. So